Hello, good evening, everyone. This is Nikita here, the co-founder and CEO of Society for Space Education Research and Development, an organization that is working towards space education and promotion of space research from the young and the bright students here and everywhere from the world. I would like to welcome you all for the SSERD Space Talk, which is an initiative which brings in people from various space background and let them share their experience of working in the space domain on various different things, and also motivate the young generation to look for different things that are available in the space domain. So today we have one of the amazing person whom we have met at SSERD and who's always been supporting us. So I welcome Mr. Gadhadar Reddy. Hi Gadhadar, thank you so much for accepting our invitation.
Hello, Nikita. Always a pleasure talking to you guys.
Awesome. So let me introduce you all a little bit about our speaker. Gadhadar Reddy is an inventor, entrepreneur, and a visionary working towards a long term goal of enabling humanity to be a spacefaring species. He was born in Bangalore in 1987. He excelled in academics throughout and understood the need to master advanced materials, especially carbon nanotubes, due to their immense applications. He is a Checheveningvening Scholar, University of Oxford, 35 under 35 in space, amazing. India France Young Leader, and also a Singularity University Alumnus, amazing. In 2011, he founded NoPo Nanotechnologies in Bangalore along with Dr. Robert Kelley Bradley, who is the co-inventor of HiPCO, with the Nobel Laureate Dr.Richard Smalley. The project was funded with a small seed money from the family and friends. NoPo stood for not possible, since everyone he met said that it was impossible to produce advanced materials at scale, particularly in India. He took it as a challenge and did not reveal the reasoning behind the name until after they produced their first nanotubes. He worked hands-on to build the first reactors, which are a technology marvel capable of operating in extreme temperature and pressure. There's lot much I can say, but yes, I would let this information to come out from Gadadhar itself. So Gadadhar, it's amazing to know what is your vision in your life and the path that you have taken to reach that goal. I request you all to take us through the through your own journey and also tell us more about today's topic, nanotechnologies for space exploration. Thank you so
Sure.
much. The stage or the screen is yours now.
Awesome. Thank you. And hello, everyone. So we'll get started, and I'll start with a brief introduction about what we are, what we do, what NoPo is all about, and then I'll quickly emerge into the nanotubes and also nanotechnology and how it's going to impact space exploration in a big way. Now, as Nikita said, NoPo is a company that's working on carbon nanotubes. Our long-term vision is to enable everyone to be able to go to space. It shouldn't be a few selected astronauts, but say you have a cool meetup, you just need to go to space and be able to do that. So how do we make something like that happen? So the answer we found was that we need extremely strong and light materials. And one such material is a carbon nanotube, which I'll be talking about in this talk. To make this happen, these are my co-founders. Dr. Kelley, he worked with a Nobel Laureate. He's one of the renowned names in carbon nanotechnology. And the professor that he did his PhD under, Dr. Richard Smalley, he effectively started this field of nanotech because of his discovery of carbon fullerenes. Gadhadar Reddy was our seed investor, and he's the one who helped us get started. He's my dad. And our advisors, Dr. Rajat, he's the guy who designed the processors and got them operational for the PlayStation processor. So if you're playing PlayStations, the first PlayStation was his creation because he was the operations guy handling it. Dr. Shivram is an expert in nanotechnology. He's the guy who sets standards for carbon nanotubes in the world. He's a former NASA person who's now moved into academics. And these are my colleagues, Santo and Aparna. Now, so what is NoPo and what have we done? So this is just a very brief, just telling, brandishing ourselves. So we are one of the top carbon nanotube manufacturers in the world. We make the world's highest quality carbon nanotubes. So we make a material that's very, very small. It's about 2 lakh times smaller than a hair strand. So the advances we have made in the material, they make us the sole manufacturers of this exciting material. And I'll be telling you why it's so exciting soon. We work with a few defense companies, all attracted to our innovations. We've been featured in quite a few newspapers and stuff. And we've also worked with ISRO for creation of super black coatings with carbon nanotubes. And so these are a lot of achievements, but we'll get into the basics right away. So we're talking of nanotechnology for space exploration. So just as we enter into this realm, I'll just take a step backwards to just trace my own journey of why we even started working on nanotech, like what's led there in this. See, my interest in space started from a visit to this observatory when I was a kid. Everyone should visit Vainu Observatory, especially on a clear light. It's one of the few places which has absolutely no light pollution. And there, when I went there and I looked up at the stars, I was mesmerized. I was like, wow, this is so beautiful. And I just can't take my eyes off it. And this is something I want to be doing. This is where I want to go to. This is where I want to visit often. And I was reading up a lot of science fiction, and everyone said that there are these amazing visions of the future. We would have massive cities come up in space. People would be living in orbits. People would be going to other planets and stuff. And then when I went back to see, okay, what's happening, people said by the 90s, we are going to be living in space. And 2020, I still am on ground. 2000, when I was thinking of these things, we're still on ground and nothing's happening. So what happened? Where did we make a mistake? Like, why aren't we a species that's already living in space? If we are already capable of going to the moon so many times and coming back, why are we still taking baby steps? And the more I tried finding answers, the more I realized that we are limited severely by the kind of materials we have on Earth. And around the 2005 timeframe, people said, okay, there is probably only one way and one configuration of atoms that could help us make these incredible leaps. And also, when we think about it, when we think about all these incredible structures that need to come up in space, we need materials that can help us build these things. We need materials that can help us take these things out to space. So we started thinking about the properties of such materials. So imagine you're living in space. Imagine you're building your like spaceships and your massive hotels and or a mining system in space. So what we need is something. We need materials that are lightweight, extremely strong, much stronger than anything we have used right now. We need materials that can be conductive, that can have properties that could be controlled, because copper, it turns out, occupies about 15 to 20% of mass of a spacecraft. So lesser weight is always good. You need a very good heat conductor to help with re-entries. You also need an excellent insulator to make sure that heat is not entering into a spacecraft, but a material that can withstand that high temperature. Space has a lot of radiation, so you need radiation resistance. Most plastics that we have today, they all turn brittle when they're in space, so you can't really use them for a long time. And you need a material that's also having a high modulus. So what this means is when you make, say, a thin sheet of a very strong material, you don't want it to flex. You want it to remain sturdy. And another ideal capability would be, imagine you're going in space and you have a bunch of micrometeorites striking at your spacecraft. So how do you know that you have a leak? And do you have to always monitor your systems to know you have gas leaks? Or could the material itself tell you that, okay, I have a problem, and does it try to protect you? So these we envisioned were properties of such a material. Now, if we look around ourselves, if you look at everything that's there, like just take a look around every device you see, every system you see, there is no single material that can have all of these properties. It just seems impossible. Just think about it. Think of steel, and does it have all these properties? Or think of copper, think of plastics, think of ceramics, and we don't. And so, what's the solution? Like, so how do we get access to something that can have all of these properties? So while searching for this, I used to like during the same summer schools. I realized that we were calculating like stability of stars. We're trying to understand like, okay, so when does a star explode? What's the lifetime of a star? How do hydrogen atoms agglomerate? And how do you explain all these things? And there's only one way that we have of explaining things, and that's from quantum physics, wherein we look at how the atomic behaviors are happening within atoms. So that was super fascinating. Okay, so you have this incredible theory of atoms that explains how things work. and why things are the way they are, and explaining the lifetime of a star, lifetime of the universe, and stuff. And at the same time, there was news of this new exciting material called a carbon nanotube that could potentially change how we live in space, how we were able to get access to space. And I was enamored. I was like, okay, so this is an amazing technology. And another interesting offshoot of quantum physics is the ability for us to work with atoms, because it gives us the basic idea of how atoms would behave. And the field of technology that deals with atoms, that deals with how do you make separate interactions happen, is nanotechnology. So that's where my attraction for nanotechnology started. And I was enamored, like, okay, this is the field, and carbon nanotubes are what I want to be working on in my life. So to just get another perspective of nanotechnology, so imagine a single marble, like say a marble that's like say the size of a fingernail, and imagine the Earth. Just try to have both those numbers make a perspective. Now, if you imagine the size of Earth and then imagine the size of the marble, and if the Earth is 1 meter in size, the marble is 1 nanometer. So that's the size difference that we are talking about. So you're looking when we say nanotechnology, we are trying to work with things that are so tiny. And I'll just this scale of things, this number that I'm talking about, is something that's always difficult for anyone to grasp because it's the dimensions are just so insanely small. So I'll just walk you through a small video that shows what this means. So this was produced by IBM back in the 70s. It's called Powers of 10, and you'll be able to just Google for it, and you'll be able to see this completely later on. So now, what you're looking at is an image of a park taken from a satellite at a height of about a kilometer. The squares that you're seeing is about a kilometer. Now, what we're going to do is to start zooming in into this image. So let me just help you with that. Yep. Here we go. So now we are zooming in. We see a few people in a park. We zoom into his hands. The hand is about 10 centimeters in size, like the size of your palm. And now we start going into his skin. So now imagine that we just went to 10 centimeters for the square. Now we are at about a centimeter in square. You're able to see his skin pores and stuff at about a centimeter. Now, as we go even smaller, you're looking at a millimeter in size. So there you start seeing the glands from which your sweat comes out. So you're at a millimeter, and now let's go even smaller to a tenth of a millimeter. So now you're seeing the blood vessels, the collagen, the fibers. So now you're looking at collagens. Now this is also the size of your hair. So you're still here. And we're at 10 power minus 4 meters. A nanometer is 10 power minus 9 meters. So we're still not there yet. This is 10 microns, the smallest size we can work with our materials of today, like say mechanical machining and stuff. This is the best we can get. Now you're looking at the chromosomes, which are still smaller. And this is still not nanotech. And we still get even smaller. Now, what you see there in that small square, that's an area which we define as nanotech, but that's not where NoPo works at. We go even smaller. That square that you see, those atoms that you see, that's the area. This square is where we work at. This is what we specialize in with nanotechnology. Now, as you could imagine, this stuff is just so incredibly small, extremely tiny. Now, one of the realizations we get when we get to make things so tiny is that we suddenly have a superpowers. It's no longer that we are dependent on what nature has to offer us. We don't have to mine the ground. We don't have to destroy the planet to get the properties we require. Instead, we create those properties from scratch. And one of the most versatile materials that mankind has known is carbon. So carbon is a material that can be extremely strong, that can be extremely conductive, that can be extremely a very good thermal conductor. It's the best known material for radiation, with the capability to withstand radiation. Under high temperatures, it can withstand up to 3,500 degrees without any kind of damage. It can be pushed up to 4,000 degrees with some of the newer additives that can be put on top of it. There's nothing that's close to this. And it can also have the ability to provide some more unique features, such as the capability to like have water filtration and stuff, which I'll just mention briefly in passing. So there's no other way versatile material. So we took this incredibly versatile material and we reconfigure the atoms in a way that would give us the properties we desire. So now, what do carbon nanotubes do? So if you were to just look up details about nanotubes, you'll find that nanotubes are one of the strongest materials known. Nanotubes, along with graphene, are known to have the highest tensile strength ever known. They're very, very conductive. Nanotubes can exhibit electrical conductivity that's 1,000 times that of copper. They are some of the best heat conductors known. They can get heat conductivities up to 2,000 watt per meter Kelvin. And also, when you have nanotubes aligned in a different direction, that same heat conductivity can reduce to 1 milliwatt per Kelvin. So it's incredible that you have a material that can have a heat conduction that varies by about 6 orders of magnitude. Just think about it, something that's extremely conductive and suddenly becomes extremely insulating just depending on the direction of the tubes. And it's also very good at radiation resistance. That's why it's used to build nuclear reactors, not carbon nanotubes themselves, but graphite and carbon-based materials today. They have the highest modulus known to any material, and they also have self-sensing capabilities. You can insert them into other materials, and we have nanotubes that are semiconducting, which can provide electrical signals that tell us if there are any forces and pressures being present on the material. So we have this incredible material that has all of the properties that we just discussed as being essential for us to be able to build stuff in space, to be able to like do it regularly, as compared to existing materials, which put severe limitations. Now, this is how nanotubes look like. So when you have bare nanotubes, they just look like this, highly fibrous, fluffy material that just seems to be wanting to fly off. It has a very low density. So a 300 ml jar will just have 1 gram of nanotubes. That's how lightweight they are. And the biggest challenge had been how to produce such a tiny material at such a small scale repeatedly again and again. So it's one thing to produce nanotubes today, it's another thing to be able to produce the same thing again tomorrow. And the dimensions that we are measuring, they all have to be within 2 atoms, which is incredibly small. So this is something that we have done at NoPo. This is an image of the nanotubes after a 1 lakh time zoom. You're still looking at big fibrils. You need to zoom in a lot more just to be able to see a single tube. And we currently are the only company producing the carbon nanotubes using this method called HiPCO, which gives us a very high control over the stability of the material. So we're able to produce the exact same material again and again. And this is what has led a lot of research groups across the globe, starting from the Japanese to the Americans, to rank our nanotubes as the best in the world. And that was a huge deal for us. To just get a perspective, India today, we do not have the technology to produce carbon fibers, while at NoPo, we produce something that's about 6,000 times smaller than a single carbon fiber. That's how advanced and that's how tiny this is. Now, what do we get? Like, what happens now? Like, now that this material is available, it took us about almost 9 years to be able to get to this point where we are able to, say that, okay, we know how to make this material, and it's not just like once in a time fluke, but we can do it again and again, and we can build new systems and produce the material again with them. So now that we got there, we're like, okay, so now people were dreaming a lot about how we could use nanotubes, how we could use these carbon materials, what we could do with these kinds of lightweight structures. And now finally, there is access that's opening up, that the availability of these materials is happening. So we are looking at some incredible changes happening in the near future by the properties of these materials. So one of them that I'm very fond of, that I see as becoming a reality finally, would be newer kind of spacecraft, such as the single stage to orbit. So these are concepts that people have talked about for almost the last 100 years. The idea is very simple. Instead of having a multi-stage rocket, you would have a single stage vehicle that goes from Earth to space and comes back. There are no multiple stages. Today, we are not able to do that because existing materials are too heavy. And if we try to use them, we end up getting very tiny payloads. It just doesn't make any sense to waste so much money to have to launch something so heavy. But nanotubes, as you saw with their lightweight, they suddenly changed those parameters. And I have no doubt that a lot of you would have seen how SpaceX with their Starship started off with carbon fibers, but had to abandon work on carbon fibers and switch to steel because carbon fibers were just so difficult to handle. Now, this is something where nanotubes come into play by bringing in their self-sensing properties and improving the properties of those off-the-shelf carbon fiber windings. That's the big difference that they're bringing to the table. And we're proud to be able to work on those cutting edge things early on. And another company that is making use of our expertise and working closely with us is Python. Python is a company that's trying to build spacecraft that land on Mars. So they're working on the last final segment of landing on the surface, and they just got funded and we're exploring carbon nanotubes and some of their structures and engine parts, which is another proud moment for us. And another interesting application of nanotubes and carbon structures in general is to use them as carbon-carbon composites. So these are materials that are like carbon atoms linked to other carbon atoms. And the major advantage is that they can withstand very high temperatures. They're extremely strong, extremely lightweight, quite durable, and they've been used already. Like even India makes use of carbon-carbon composites. Traditionally, these are very difficult to manufacture because they require specific structures to be formed inside carbon. And this is something that the nanotubes simplify by being part of the structure. And that's an area of exploration for us, where like the sudden access for high strength material suddenly just changes not just space exploration, but also things on the ground. And this is one interesting application. This is like from nanoparticles and how nanotech impacts our endeavors in space. So one of our collaborators and one of the researchers I know in Oxford called Andrew Briggs. So he was talking about this. Like, so it turns out that they had this thing. So this professor had somebody walk into his office, and this person wanted to see, okay, everyone's talking about nanotechnology and nanoparticles. So what happens if nanoparticles get into the ground? Is there a possibility that it could be contaminating the soil? So he wanted to measure nanoparticles in the ground around areas where there were research labs located. So he started taking samples and giving them into an instrument called a mass spectrometer to see what happens. And to his surprise, he found that there were nanoparticles present even in areas where there were no labs. And it was insane. Like it's like, okay, there is no lab, but there are nanoparticles, and nanoparticles are supposed to be only produced by human beings. So what's happening here? So when they measured it, they found that, okay, the concentrations of different elements was varying in those areas where they found the nanoparticles. They started digging deeper. There's been a lot of work in this area coming from the Chinese too. So they found that when you detect a higher concentration of a nanoparticle on the surface, it most likely got there because of some spurt and gases being released from from below the ground, and that would mean that there would be an ore of that particular mineral or element in the ground that's being pulled up to the surface. So if you could detect nanoparticles, you can actually detect massive mines. And this theory has been proven. So if you just have a small mass spectrometer and you could measure nanoparticles on the surface, you can actually detect mines having those minerals directly below you on the ground. And this is one very, very interesting application. So just imagine the prospects for this, for prospecting asteroids or for prospecting other planets which have small geologic activities. You can, if you detect nanoparticles, you're actually going to detect your fortunes there. Another very interesting application of nanotechnology has been in the Breakthrough Prize, the Breakthrough Initiative. The idea is that we send a vehicle that goes all the way to the Proxima Centauri B. So this is a quite an interesting challenge. The idea is that a small chip that's made of a solar cell, most likely made of graphene, would be bombarded by a high power laser. So carbon is the only material that can withstand so much of energy. And in fact, a lot of the laser protection systems, they make use of graphite and carbon-based structures simply because they can withstand so much energy without damage. And these would be powered by a massive laser, a sail being bombarded by it, that would accelerate it up to about a 20% speed of light. So without access to nanotech, this would never happen. And then this would sail continuously and get to the nearest star system and then beam back a signal. Some of the early versions of this, so they're called star chips, and these are called sprites. They've actually flown on PSLV. Now, this did not use any kind of nanotech, but the final versions would be making use of that. The smaller chips were called sprites and they were launched. Another area where nanotech makes another huge difference is medicine. So imagine zero gravity, like very difficult for blood to behave as it does on the ground. Wounds do not heal quickly. So when you have these very tiny motors and tiny devices in your bloodstreams that are carrying all the medicines required and release them in slow spurts, which are under human control, so that makes a huge difference. So this is now an interesting field of study. Now, these applications are not just for space because they make a huge difference down here on the ground. cancer medication, they require to be released very slowly. And these devices give us the capabilities. So even carbon nanotubes have been used in such a way for cancer treatments, wherein they're like embedded with marker molecules sent inside the body, and then infrared beam is shined on the skin. The nanotubes absorb the IR light, they heat up, and they destroy those cells. So these are experiments that are ongoing, which have shown a lot of promise today. So these were some areas. Now imagine that we're all having lighter rockets, say the single stage orbit vehicles come into play. We're able to regularly go up in one round. So if we need to travel longer, we need to have the ability to refuel. We need to have the ability to fuel up as we fly. And this is where orbital propellant depots come into play. So people have always talked about them. And I strongly believe that the right kind of orbital depots would be the ones that store water. Because for humans, as you would have read, water is the most essential thing. We could live without food for quite a few days, but without water, it's sudden, it's guaranteed death. So water is going to be an essential commodity for anyone in space. One of the interesting things about water is that if we are able to split water, we can produce hydrogen and oxygen. Now, this water splitting is an energy intensive process.
Gadhadar, can you hear me?
Hello?
Yes, Gadadhar, we can hear. We can hear you.
Yeah, sorry, I got cut off, unfortunately. I'm back now. All right. So, shall I continue, Nikita?
Yes, Gadadhar, you can. One second,
Sure.
Suchay.
Awesome. Sure.
Can we continue? Okay.
Awesome. Sorry. Sorry about the interruption. So now orbital propellant depots, they make a huge stability to actually refuel, to be able to travel further, to be able to travel longer than we can ever envision with the existing systems. So this is one area where nanotubes play an important role. So imagine, just look at a glass of water. The amount of energy required to split water is actually very tiny. Sunlight has enough energy in the right wavelengths to actually split water. But to do that, you actually have to have an ability to stop that light, to be able to have a place for the photon to impart its energy. So about 1.4 electron volts is what's required to split water. So if you can have a surface that can provide such a band gap, that could then help you break water instantly. And it turns out that nanotubes actually have such a property. They actually give you a surface on which we can break down water molecules into hydrogen and oxygen. And this is a work that's also been done by the Japanese to carry out and see if that's really true. It's been produced where carbon nanotubes of a very specific kind have been utilized on a surface to split water directly by using light, which is another very, very interesting application. So imagine we are in space, we have these big water tanks, and you just have light pass through them and it converts to hydrogen and oxygen. So this is stuff. So as you could see with nanotechnology, we've been able to make, we've been able to modify and create systems and enable things that in the near future are going to change how we live. They're going to change how we can thrive on the planet and also beyond the planet. And we've reached a point on the planet where our human population, as we have grown further and faster, we've kind of like ruined a lot of the planet. So it's like it's difficult for anything to survive here while we live here. So what I strongly believe in is that at some point, the Earth would just be a sanctuary planet where humans that are not conscious would live, while everyone else that are aspirational, that want to do something big, want to create things and take control of things in their own hands, would leave the planet and would go beyond. So this is what I believe. And we are just creating all those enabling technologies. And most often when we create an enabling technology, it's against odds. It's always difficult. And so that's what we.
um, Wonderful information that we were not aware of using nanotechnology in various applications, and being the space enthusiast, knowing where it could be used in space was amazing. So, Gadada, we do have few questions that we've collected from the audience.
Mhm.
We'll take a few here, and also we have few questions that are there live collected on our YouTube and
Mhm.
Facebook.
Mhm.
So yeah, the first question for you, Gadadhar, is we recently heard a talk by NASA Administrator Jim, where he mentioned that NASA is also working on advanced materials, but from ISS. So you have been working on advanced materials like carbon nanotubes from here on Earth. Could you just tell me what could be the difference between having working here on Earth, the same material on, or let's say in space? Yeah.
Sure, definitely. Yeah, that's a very good question. And the NASA center that does a lot of work on nanotech is actually the NASA Ames Research Center. And while I was in Singularity University, we were on the same campus with like rubbing shoulders with folks there and the directors there. So now one of the big differences that happens is like say nanotubes. Now we spoke about all these properties of nanotubes. And nanotubes are being tested on the space station by various research groups. So what they do there is they have these bays in which they keep the nanotubes and expose them to space. So we think space is empty with nothing out there, but it turns out that it's not. It is like quite active with very extremely energetic particles. So there is atomic oxygen that's present from the ozone layers that's available in the low Earth orbit on the space station. So when the nanotubes are exposed to oxygen, they get destroyed. That's their biggest weak point. So this is not something that we see regularly on Earth because here we know oxygen is bad with high temperatures. We never use that. But how is atomic oxygen going to behave? We never know. And that it's hard to get simulations. So we just have to let it behave with a real world experience and see what happens to it. And similarly, solar flares. or some other phenomena that we do not have on the ground, that can only be seen by testing the material against the circumstance where it's going to be used. So that's why it's essential to test them up on the space station.
That's really good to know. And we have one question from one of the student, I suppose, or recently graduated. Anyways, the question is, any opportunities in NoPo Nanotechnologies for a student who has pursued bachelor's in nanotechnology and is pursuing master's in material science and engineering? Like, if there's anyone from this background and who wants to do something, do they have opportunity? If yes, how do they approach you?
Sure. So we do have a lot of opportunities. We like are continuously on the lookout for people. So what we have figured over time is that the basic degrees don't really matter. It's really the passion of the person that really matters. So our hiring process also reflects that. So that's why we do not exclude people from a different domain simply because they don't have like a degree that says nanotech, because we kind of understand that degrees don't mean much nowadays. And so what we have done is they can just visit our website. We have a link called jobs.nopo. Click on the careers page and they can apply for quite a few internships. So our idea is that we get people as an intern, so they get to see how things work, they learn about it, and then we upgrade them into a full-time employee, because we know that there's nobody who has experience with the material after we're the only ones making it.
Awesome. I mean, it's really good to know that yes, you're so free, and in fact, we at SSERD believe the same thing. It's not the degree, it's not the marks, it's not those things which actually matter. It's all the skills and the way you think and what you're determined to do. It's really good to know. And there's one more question on YouTube that we have got from Sai Ganesh. The question goes like this: can nanotechnology improve the communication with the spacecraft? Like anything connected to
So,
this?
so when it comes to communication, nanotech by itself wouldn't make a huge difference. It's going to be about how it's going to be used. For example, like say in microwave transmission and absorption, people nowadays are moving towards these phased array antennas where you want tiny antenna structures that can, look at a big beam. And people are also looking at things called metamaterials, which are materials that can bend light or bend radiation in a way that's relevant for them. So these kinds of structures can be built with nanotechnology. That metamaterials are at 100 nanometers for certain frequencies and not for all of them. So that way it can be helpful. It's really going to be an engineering design on how the system is going to be. And I also remember there was a question about how this could be used as a way for observation for satellite telescopes and stuff. So what I see there is like nanotech enables us to build tiny spacecraft that could be distributed over a very wide range, which could then create a massive antenna. It would be like a virtual antenna that's capable of receiving signals from far off places. So that way, as an engineering system, it would make a huge difference. From a material perspective, they make differences from the metamaterial properties.
Amazing. There are a few questions which I would like to just combine and ask you, though you did cover while as some part of your presentation. The question is, what kind of nanotechnology can be used in space mining and mineral mining, or even the space militarization?
Mm, yeah, that's a good one. So on mining, like as I was saying, the just detection of nanomaterials is going to make a huge difference to know where to dig and where to find the fortunes that anyone's going to mine from. And when it comes to space militarization, I think nanotech is going to play a huge role, particularly carbon nanotubes, because these are materials like so space projectiles are going to be slow, laser weapons are going to be needed. Laser weapons, the only protection against them are carbon materials, and they're also the only offense because they can withstand so much heat that no other material can, and everything else would just fizzle out immediately. And they would also make a huge difference from their stealth properties, because when it comes to microwave absorption, nothing beats these materials. And we call things as engineered materials, wherein say you have damage in space, so you get hit by something. Now, how do you fix it rapidly? So there have been experiments where people incorporate these gel-like materials, all enabled by these new advances. So these gels start releasing and they start self-healing. So it's like you can imagine like your skin now being extended to space to be able to protect you. So these kinds of advances are there, like the self-healing materials is a search term, and you'll find a lot of literature about it.
Amazing. So when you said fluids or liquids, there's one interesting question. Can we use nanofluids in space? I mean, my question is, I mean, with this question, I mean, I have a question. Do we have something called nanofluids? And if yes, the question is, can we use nanofluids in space and how?
Sure. So, see, what happens is the term nanofluids is used. Like, so it's kind of like nanotech is kind of used in a good way, and sometimes it's also used as a great marketing term. So, whenever we say there is a nanoparticle present inside a fluid, it becomes a nanofluid. That's how it's really defined. It's not really a very tiny amount of a fluid. So, if you have these particulates, like, so most often they are stable suspensions. They do not have any behavior that's affected by gravity. So they still remain the same suspensions even when they get to space. That wouldn't change. So the fluids would be usable, but you'll just have to account that the systems are capable of using it. Like, for example, like say it's being used as a hydraulic fluid, and you have nanoparticles inside it to provide, say, heat transfer. Now, it would have the heat transfer within the fluid, but now which direction is the heat going to transfer out of? Like on the ground, it's always going to go up. There, it won't be that way. And so those things will have to be taken into consideration. So the fluids itself, yes, but the engineering systems around it, not directly usable from Earth.
Okay, okay, good to know. And I have one another really good question. The question goes like this: where do we use the? I mean, what are the applications of nanotechnology in our day-to-day life? Like, if you could just tell us, like, where are we using nanotechnology in our normal
Sure.
life?
Sure, definitely. So today, right now, a lot of the cosmetics, they make use of nanoparticles. So like sunscreens make use of nanoparticles because they're very good at absorbing UV radiation. So titanium dioxide, that does that. And a lot of washing machines today, they advertise silver nanoparticles. These are very tiny particles of silver. Samsung especially does that. So these are good antibacterials that are utilized. And surprisingly, almost every car bumper in the world actually has carbon nanotubes inside them. So they've been in use since the 80s, made by a company called Hyperion. So these are used as a reinforcement inside for the plastics to make them stronger, to be able to withstand cracks, and to be able to last longer. So these are just a few things where nanotech is already penetrating our lives. Every electronic item that we use, from our phones to computers, they're all having transistors with gate width less than 100 nanometers. They're always less than, like now we talk about 7 nanometer technologies. All of that is nanotech by definition. So most of the advances we see that's changing our life today is being powered by the human ability to control atoms. So it's no longer that we are waiting for nature to give us something. It's like, okay, we're like, okay, fine, nature, you're slow. We're going to just create it ourselves. That's what's happening.
Okay, great, great. Gadadhar, what about nanotechnologies being used for space debris removal? Like, do we have any applications over there? At the same time, another question we have on YouTube is about the spacesuit, astronaut spacesuit. Like, do we have any application in that area as well?
Yes, definitely. On the space debris front, people have been looking to make long tethers. So these are long ropes of the high strength material that's like a net to capture these debris. So there are a few folks working on such kinds of nets. And that could be an interesting one. When you have a high strength tether, it just changes the equation completely. You can just like latch onto anything. And when it comes to spacesuits, yes, there is some very interesting work happening in Boeing. The friend, so she's working on spacesuits where they embed these nano materials, especially carbon nanotubes, into the suit. So what this does is, imagine people get to Mars, we get to Moon, and we're walking on the surface. There's just so much dust, and Moon especially has this problem that everything is charged up, everything wants to just stick to your clothes, and it becomes irritating. And they're also very sharp; they can cut through the clothes. So what they did was to embed thin wires of these nanotubes inside the suit. They press one button, and it just repels all the dust. So it's like an instant cleaning spacesuit. I think that's also been patented, and there's a lot of work going in that area for newer generation spacesuits. and also having the ability to monitor people within the suits, having very tiny sensors to monitor every biological function. Those are also being enabled by graphene and nanotubes and several other nanomaterials. So this is how things are moving towards. Like you have sensors continuously monitoring a person, continuously knowing what's happening to them, continuous data about all the physiological features, and also protecting them externally by making sure that all this dust is not entering their bodies and destroying them. So this is stuff that's happening
Lovely,
and in
lovely.
an
I mean,
advanced research phase.
amazing. I mean, I'm just kind of telling one point, and everywhere there is possibility of using nanotechnology. I could just
Yep.
imagine how important it is, or how important it is going to be, at least in the future. Now,
Sure.
for example, there are few students who want to work in this field, nanotechnology.
Mhm.
What do you suggest them? Like, what is that they have to do? Like, for example, when we say rockets, we look at how do we bring down the cost, or what kind of good propellants we could use, different ways that we can work in the field of rocketry. Similarly, if anyone is looking at pursuing their career, or at least their research in the field of nanotechnology, based on your experience, what do you think that they have to concentrate? What do you think it is so important that we need people to work on?
Sure. See, one of the limitations that exists when it comes to either rocketry or nanotechnology is that people don't have practical experience. Like, unless you go out and build something, you're not going to be able to like build a career out of it. It's like if you say, okay, I'm going to sit on my computer, play Kerbal Space Program forever, and then I know all the orbitals and stuff. It's great, but it's not going to let you take off on a rocket. You need to actually go out and build it. So it's very important for people to be able to find opportunities that let them get a hands-on experience where they get to build things, break things, and create things. So that's the most important thing that I would advise. So immediately, like it's very very important to experiment. It's very important to learn how things behave, and that's probably the only way that they can learn stuff. So my whole advice would be try to get as much practical experience as possible. Try to do small experiments by yourself. You don't have to wait for anyone. Like for example, we have a field called layer by layer self assembly. So in layer by layer self assembly, you create one atom thick surfaces. And the process for making them is actually incredibly simple. You just have to, it's as simple as like and dipping slides inside them, and you can create such structures. And Bangalore, especially right now, has some very, very good nanotech research happening with some top notch facilities. And it's also spreading across the country. So make use of the facilities. IAC, even our office and our lab has so many of the facilities for working with them. And all we look for is a lot of enthusiasm and passion to want to, build stuff and create things. And then there's always a lot of help.
Amazing. And Gadadhar, this must be a very interesting question for all our audience, which just came in my mind though. Um, what about the prices? Like, how much does it cost you to, make that one carbon nanotube? Or like, let's say, if you can also talk in terms of mass, and
Mhm.
like, tell us in terms of money. What is
Sure.
nanotechnology in terms of money?
Sure, I can do that. So I'll just give an analogy before we get into the prices and look at how things progress. So the best analogy I always get is electronics. Like if you look at the phone or the computer that's making this conversation happen between us right now. So that phone is made of transistors. It's a lot of transistors inside it. The first transistors that came out were in the 60s. Now, can you guess the price of the first such transistor? How much would it have cost?
Mm, probably some thousands.
Mhm. So, good guess. It was about 7 lakhs for one transistor. So, the
Okay.
first transistor cost 7 lakhs, and today we have phones which have almost 100 crore transistors inside them. So now nanotech and carbon nanotubes are also in that stage where they're like early stage materials that make a huge difference that are also incredibly expensive. And so they're being targeted at areas where they make that difference, where that expense doesn't have a problem, where somebody can actually pay for that, and that makes a difference in their lives. For example, the people who paid the 7 lakhs for one transistor were actually the US military. They did that because so as you know, like US missile research was what eventually led to all their rocketry, and the Maoists did it with the moon landings and stuff. It's the same was with the Russians and the Germans too. Now, with the US, what happened was as they were developing their military rockets, they found that they needed good guidance systems to be able to go hit their targets. And those could not be built with vacuum tubes because they were just too heavy. So they had to use transistors to reduce mass to be able to do that. So what we have done ourselves is also to find areas which require tiny amounts of nanotubes, which make a difference that no other material can compete with. There's no way we can achieve such a performance. And in those areas, people can pay a lot. Like right now, our nanotubes, a gram of it, it costs between 35,000 to 50,000 rupees. So it is quite expensive. So, but the areas we target, like say when we talk of spacecraft structures, or when we talk of these aircraft bodies, or when we talk of water filtration, so there we end up using only a few milligrams of nanotubes. So that way, like the amount of nanotubes required on a cost basis is incredibly small, even though on a per gram basis, it is quite expensive. So that's how we are handling the cost in the system.
Okay, now I got the answer. Like it's amazing, and I can also see how big is the industry, how
Mm.
important it is, and many things. So yeah, so now just probably one last question related to this money or economic factor. Now, if someone, or like for example, let's take a satellite which uses nanotechnology, is there any
Mhm.
price reduction that happens, or is, like, we know for sure it's going to give a good efficiency, or there's so many ways that it is going to be good, but what about the price?
Sure, I can just give a quick analogy. So these are made up numbers, not very precise numbers. Now, today, when there is a satellite being launched, say a small CubeSat or a small satellite, so generally the structure or frame of the satellite is made using an aluminum based body. So it weighs about 6 kilograms. Launch for a small satellite costs about $10,000 to $20,000 per kg. So people are going to spend close to, like, say, 6 kg, 5 kg mass, $20,000 per kg liftoff. So about $1 lakh is what's spent on lifting it off into orbit. Now, by using these carbon nanotube or a nanotech-based material, that mass comes down to about 20%. So instead of 6 kgs, you're only looking at about 1 to 1.5 kg being launched. So your launch price is still the same, but now you're launching so much lesser, so you save $80,000 right there. So this is how the numbers add up. So because of, even if the upfront cost is higher, a kg of aluminum is going to be what, 300 rupees, 300 to 500 rupees. A kg of nanotubes being embedded inside the structure could come to around $10,000. But then the overall economics is that it's so much cheaper than actually launching it with aluminum. That's how it makes a difference.
Amazing. That was a good analysis and explanation given, Gadadhar. Thank you so much, and I hope this all the information that you shared will surely be used, at least one among our audience, for the betterment of our space ecosystem, or let's say about the let's say in terms of the whole world. And I would
Mhm.
like to thank you on behalf of everyone from SSERD and the audience for taking out the time and talking to us about the wonderful work that you are doing and how it's helping everyone. And it's amazing. Thank you so much for accepting the request and joining us on
Sure.
this
Thanks a lot.
Saturday evening.
Sure. Thank you so much and appreciate that. Like, if anyone wants to reach out, feel free to do that. I'll be happy to help in however way I can. Thank you.
Lovely. Thank you so much, Gadadhar. And dear audience, this was space technology and connecting it to nanotechnology. Now, you all need to wait for until the next talk, wherein we bring in another amazing person from another amazing background and share their experience. Until then, stay safe. Thank you so much, and let's explore the space. Bye.